received his doctoral degree from from Queensland University, same as me. But my master degree was there. So today we will listen and learn about the recycling, the mineral kind of mineral processing from secondary resources. Okay, Pak Edi, time is yours, Pak.
Okay, let me share my how to share a screen, Pak Imam.
Yeah, there is like share screen, Pak Edi, in the
and then
yes.
only share PC audio on screen portrait mode. Which one?
Yes.
Which one should I put?
Share PC audio also, Pak. Yeah.
Share PC audio.
Yeah.
Okay. Sorry, it is about and now
you can select the screen you
which
want
one
to share.
should I select, Pak Imam? Share PC audio on screen
PC
portrait.
audio, and then it should some option in the
on
select
screen
content to
portrait
share.
mode.
It's up to you, Pak Edi.
On screen portrait mode, should I?
Yes.
Okay. And then sorry.
It should come. Dan can you make Pak Edi as co-host?
Sorry.
It's okay, Pak.
Okay. Okay. Let me. Okay, so. Okay. Here because maybe okay. Screen sharing watermark setting. All attendees can share. No. Only the host can share. Which one, Imam? I cannot share my file, Pak Imam. How to share my file?
It should come in your screen when you click. You have to click first, like PowerPoint, or I don't know, Pak Edi. It's depend on the application you open in your computer. It's like Zoom. Maybe can you start from the beginning again? Share.
It is different with the Zoom. When I click a share screen, and then my file will appear, and then just click my file. And this one is not like that. Screen sharing watermark setting like that. All attendees can share. Screen sharing permission only the host can share. On screen portrait mode. So when I click share screen, okay. Now let me choose my PowerPoint. Okay. Okay. Now sorry, Pak Imam. Sorry,
It's
Pak
okay,
Imam.
Pak. It's common because it is not common in Indonesia. We are using Google Meeting, so
usually I use okay. Let me. Sorry for everybody.
That's okay, Pak Edi.
It is a bit panic, Pak Imam.
Don't panic, Pak. If panic, everything will be not going very well. So take your time. We still have time, Pak.
Okay, desktop one. Desktop one. Oh, which one must be shared? Desktop. I need to click what?
Yeah. In the desktop one, below that there is some row. I think some application like PowerPoint. Yes.
Okay, which one?
No, not this one. This is a website user, Pak.
It's different again. Sorry, Pak Imam.
You can close, Pak.
Close. How to close?
Move your cursor to the top.
Okay, stopping. Okay, and
yes.
Then
select other screen again. Share screen again.
And again, share screen. Okay.
Yes. And there is some.
It has happened.
Yeah, below.
That is okay.
Perfect.
Now.
Yeah, you should full screen.
Okay.
Yeah.
Sorry.
If Eddie, yeah.
Here we
Perfect,
go.
Pak. Yes. Yeah.
Okay, thank you,
It's
Pak
time,
Imam.
Pak.
And
15
sorry
past
about
10. It's
everybody.
okay. It's okay, Pak
Take
Eddie. Yes.
a bit time because it is VOV is not familiar for me. Even though last year I used the VOV because I need to reinstall the VOV and a bit different with a previous VOV, I think. Okay. Once again, good afternoon or maybe good morning for some people attended the course here. My topic is physical exploration of primary and secondary resources. A little bit a brief profile of me. My name is Edin Sanwani. This is my contact, phone, fax, mobile, email, my institution, Department of Metallurgical Engineering, Faculty of Mining and Petroleum Engineering, Bandung Institute of Technology. My education background, I was graduated from ITB for my undergraduate in metallurgy, and then my master in minerals and coal processing also from ITB. My PhD from JKMRC, Julius Krusnit Mineral Research Center, University of Queensland, Australia, in minerals process engineering. My some teaching subject, you can have a look here: mineral and coal processing, mineral processing plant design, coal preparation and washing, coal preparation and washing plant design, unit operation in metallurgy, also engineering process, metallurgy, experimental design, and optimization. You can have a look also my work experiences. So basically now I am head of mineral and coal processing laboratory and also as a staff member at Department of Metallurgical Engineering, ITB. So that's my brief profile. Okay, sorry. The course contents basically will be introduction, a little bit about the introduction, and then part 1, physical exploration of primary resources, part 2, physical exploration of secondary resources. Okay. As an introduction, you can have a look about the sources of metal. Firstly, from primary resources, which is basically natural resources, for example, from ores. So any metal we use now basically firstly come from natural resources or ores. Yeah, a lot of metals. You can mention any metal here. For example, copper, gold, lead, zinc, etc. And secondary resources now is from secondary resources, which basically it is recycled materials. We can have metal from a printed circuit board, for example, or PCB, etc. Now, the question is, what is the processing from the resources, which are basically primary resources and secondary resources to become metal or metals? Yeah. So that's the main topic in this course. How to process the metal, how to process resources from primary and from secondary to become metals. So in the first part, we will talk about physical separation of primary resources. Because when we talk about secondary resources, the technique we use at the moment basically it is a similar, even though not really the same, but in principle, the technique is a bit similar in terms, for example, how to reduce the size, how to separate the metals in secondary resources from other metals. It is similar when we need to separate minerals and primary resources from other minerals. Okay. So now, now we will discuss about the basics of mineral processing. Okay. In a very simplified way, mineral processing can be summarized into two stages. First, to liberate valuable mineral or minerals from gangue. Gangue is non-valuable mineral, which is usually in the process. It is called usually as tiling, and because it is a non-valuable, usually it is sent to be a waste. So the mineral which is a not valuable mineral is called as a gangue minerals. So first, to liberate. How to liberate? Because basically in the earth, this mineral is with the other mineral is in association. And then the first stage is how to liberate the association of these minerals. Second stage is then after liberation, how to separate valuable particle from gangue particles. So then at the end, we will have a product which is usually called as a concentrate. Okay, that's the main stages in mineral processing. First, how to liberate, and then after liberation, how to separate valuable particle from non-valuable particle or gangue particles. Okay, it is an illustration. Yeah, it is an illustration. If you look at here, say this is a big particle contain of two kind of minerals. First mineral inside a particle, blue in color, say it is a valuable mineral, and the green in color is a gangue mineral. It is to simplify the illustration. A big particle contain inside the particle is two minerals. Okay. The basic principle in mineral processing is basically how to separate the blue particle, a blue mineral, from a green mineral. It is as simple as it is, even though in reality it is not so simple. Okay, because many aspects. Okay, back again to this illustration. So imagine one particle, a big particle, and in mineral processing is how to separate the blue mineral from green mineral, the valuable mineral from gangue minerals. It is just an illustration of two kinds of mineral in one particle. Okay. In reality, a lot of minerals. Okay. Okay. If we reduce the size of the particle, become a smaller particle, from vertical maybe become 1, 2, 3, 4, 5, 6, 7 particle, just for example, then we will have the result, a smaller particle. Some particle may be already liberated. For example, this one, the blue one already liberated. The other, maybe there are a couple number of particles already liberated of the gangue mineral, but some is still in association. Okay, so it is if I look at this particle, maybe it is easy to separate the blue particle from the green particle, but it is still impossible to separate the blue particle from green particle because still in association. If we say reduce the size become smaller by next stage of size reduction, and the result may be become more particle, smaller particle, and more particle having already liberated minerals. For example, here, say, look at 1, 2, 3, 4, 5, for example, more number of particle already in liberation. But still, in fact, usually it is difficult to liberate become 100% depending of the original characteristic of the ore. And so this is here, how to liberate. By doing the liberation and by applying the size reduction, we will have some particle already liberated, even though maybe some small number of particles still having in association. That's the principle of a liberation. Maybe in reality, we don't need to really liberate 100% of valuable mineral, because if we have to do that, the energy become excessive, energy become so high. So then usually the limit to do size reduction usually in some stage, optimum stage, whether we need to 1 stage, 2 stage, or 3 stages. It is depending once again the characteristic, the original characteristics of the ore. Okay. After liberation, maybe it is enough to have, for example, 90% of liberation, 80% of liberation, depending once again the mineralogy of the ore. After the liberation, then okay, back again to liberation. Usually liberation is done by comminution, which comprise of 2 main stage, crushing and then grinding. There are a couple number of equipment in crushing. For example, jaw crusher, giratory crusher, cone crusher, roll crusher, HPGR, high pressure grinding roll, etc. And then after that, grinding. It can be autogenous mill, sack mill, ball mill, rod mill, tube mill, ISA mill, etc. So in doing the liberation, usually in industry, we need to do crushing and then grinding. Whether and how many stages in crushing, how many stages in grinding, it is once again depending on the characteristic, especially mineralogy characteristic, the hardness characteristic of the ore, to do comminution. Okay? Once again, in this stage, we need to liberate. So the keyword is liberation. The liberation. Okay. Maybe we need to reduce the size of particle from mining activities. Say a particle having a size of say 80 centimeter. And then we need to do comminution until, for example, 100 micron, because we need a particle 100 micron to have a reasonable degree of liberation. So then, how many stages of crushing, how many stages of grinding, that's that we need. We have to do some testing, and then after testing, we can design the stages of crushing and grinding. This the first main stage of mineral processing, which basically how to have a reasonable liberated particle. Okay. After we have liberated a particle, the second stage is how to separate. To separate valuable mineral particle from gangue particle. For example, here in the illustration, how to separate the blue particle from a green particle. This process is called as concentration. Yeah. There are a couple number of technique and a concentration. Firstly, the oldest way or the oldest technique is gravity concentration. In doing the separation of valuable minerals from gangue minerals, basically the separation is based on physical characteristic, the different physical characteristic of the particle, whether different in specific gravity, different in magnetic characteristic, different in electrical conductivity, or different in a surface characteristic of the mineral. So that's why there are a couple number of technique in concentration. Why? Firstly is gravity concentration, which basically this technique is based on the difference of specific gravity of minerals. For example, if the blue particle here as an illustration having high specific gravity, whilst the other, say the gangue particle having low specific gravity, so there's a potential to do gravity concentration. There are a couple number of technique in gravity concentration. For example, Swiss box, shaking table, jig, Humber spiral, Nelson concentrator, Falcon concentrator, etc. The other technique is heavy or dense media separation. This technique using a media having high density of media, for example, a dense media cyclone, dense media pulp, etc. This technique is usually used in cool washing plant to separate clean coal from the reject. Okay. The other technique is magnetic separation, which basically separate the minerals based on different characteristic of magnetic characteristic. It can be low intensity magnetic separator or high intensity magnetic separator. It can be dry magnetic separator or wet magnetic separator. The other is electrostatic separation. This technique is based on different characteristic of electrical conductivity. So if say the blue particle having good conductivity, whilst the green particle in this illustration is bad in conductivity, electrical conductivity. So then, if like that, we can apply electrostatic separation. For example, high tension separator. Now flotation. Okay, flotation. Flotation is a technique and using the different characteristic of the particle surface, whether the particle is easy to attach to bubble or it is difficult to attach to the air bubble. That's the principle of flotation. Some technique in the flotation is mechanical flotation using mechanical flotation cell, for example, Outokumpu cell, Wemco cell, Svedala cell, which this equipment widely used in a flotation plant. The other column flotation cell, pneumatic flotation cell, for example, Jameson cell. So currently, flotation is one of the technique used widely in mineral processing plant. Yeah. The other technique could be electronic sorting. Electronic sorting is based on conductivity, but different with electrostatic separation here. That's a sorting. Okay, sorting. Okay, these are some technique in concentration. Later on, we can have a look at this technique also have been used in or for secondary resources. Okay, so that's why the first part here, it is about principle in minerals or primary resources, and then later on it is easy to understand to be used in secondary resources. Okay. This figure shows applicability of comminution equipment. You can have a look here. The hardness of material, most hardness of material from a sticky material, very soft, and then number 1, 2, 3, this most number, and versus the size of particle. You can have a look here. The size of particle and the hardness and the equipment, the kind of equipment which is used in the industry. For example, 1 meter particle, usually we use jaw crusher, giratory crusher to do a comminution, to size reduction, and so on. This is just to show the applicability of comminution equipment based on the size of particle and the hardness. Okay. Okay. This is the picture primary crusher. Once again, crushing could be in only 1 stage, or maybe 2 stages, or 3 stages, depending, once again, the size of particle and the hardness of the particle. That's the main factor. The main factor or the main variable in selection of comminution equipment. Because each equipment has limitation in doing size reduction, so you can't reduce the size from 1 meter directly into 100 micron. No, you can't do that. There is no equipment to do that. Even though there is, the energy will be so high, which may be economically it is not feasible to do that. So we need to do some stages of crushing. It could be primary crushing, secondary crushing, and maybe primary crushing, secondary, and tertiary crushing. After that, we need to do a grinding. We can use autogenous mill, semi-autogenous mill, hammer mill, etc. Ball mill, usually in industry, these are the stages of comminution, crushing and grinding, because the limitation of the equipment, and we need the efficiency of the process. That's why we need some stages, and also the main stages of crushing and grinding. Here is the example of primary crusher. You can have a look here. This is the crusher. And the right side is a schematic figure of a jaw crusher, a black double toggle type jaw crusher. Okay. Look at here the particle from the truck, and then it is fit to the hopper. And then from the hopper using a belt conveyor or a feeder, and then it is fed to the jaw crusher, so that the big particle will be reduced. After that, sent to the conveyor to next stage. Here is an example of the other equipment of primary crusher, giratory crusher. Yeah. So in industry, some industry use jaw crusher, some industry giratory crusher. That's the most crusher used in industry. Okay. Okay, the other crusher could be hammer mill, double rotor impact crusher, single rotor crusher, double tooth rotor crusher. You can have a look here. Double tooth rotor crusher usually used widely in coal, yeah, in coal, not in mineral processing plant. It is used usually to reduce the size of the coal. Double tooth rotor crusher. Okay, and then secondary or a tertiary crusher. This is the example. Some equipment usually used in the stage of secondary or tertiary crushing. Crusher, roll crusher, for example, for roll crusher, double tooth roll crusher for a secondary crushing. Once again, double tooth roll crusher is usually used for coal as second stages or secondary stage of crushing. The other here, for example, is high pressure grinding roll, HPGR, which basically double roll crusher with a specific mechanism. So that's why it is called as high pressure, using the high pressure. One advantage of the HPGR is reducing in energy consumption because the principle of high pressure here. Okay. The other advantage, the product of particle, the reduced particle having a micro crack. Yeah? The particle is having a micro crack, so that for a next stage, which is grinding stage, it is easier. So that maybe the energy consumption for grinding stage will should be lower. That's the advantage of the HPGR. Look at here the example of the crushing circuit at gold processing plant Pongkor, PT Antam. Run of mine ore from mining area, firstly go to apron feeder and then to jaw crusher, the product. After that, go to the screen, the oversize, go back to the cone crusher, and then particle has been past the screen, will go to next stage. And then the product of this crushing circuit is a fine ore in the fine ore bin. This is the data of crushing plant throughput at gold processing plant Pongkor, around 100 wet metric ton per hour. This is the kind of primary screen and secondary screen. Yeah. Okay. Okay, well, sorry. Okay. So basically, there are two stages of crushing. Firstly, primary crushing, which is operated in open circuit, and second stage of crushing, the crusher is a cone crusher, closed circuit with the screen. This is the closed circuit between crusher and the screen. So basically, generally, in primary crushing, always operated in open circuit. But in the last stage, and in this stage here, the second stage should be in closed circuit with the screen, so that the product will be more homogeneous. Now the grinding. This is the photograph, the example of equipment of grinding. For example, a sack mill, semi-autogenous mill, a ball mill, other picture of the ball mill and a rod mill. Okay. And this is the example of milling circuit or grinding circuit at coal processing plant at Pongkor, Antam. The main equipment is a ball mill, which is in circuit with the closed circuit with the hydrocyclone. So from fine ore bin, the crushed ore will be delivered, transported via a conveyor to the ball mill together with thickened ore slurry, because the characteristic at this plant, the ore also from slurry in the mining area. Yeah? So that together with the crushed ore is fed to the ball mill, the product, and then discharged to the hydrocyclone. The product of the hydrocyclone, which is the overflow and underflow. The underflow will be sent back to the ball mill, and the cyclone overflow. That's the final comminution stage, the product of the comminution stage, the cyclone overflow with the target here. The pH should be 74 micrometer. Why this is the target? It is regarding with the characteristic with mineralogy. You need to reduce the size, the size of the particle. If we back to the crushing circuit, the feed, the maximum size of the feed enter to the plant is around 40 centimeter. And then by crushing and grinding, at the end, the target size is 74 micrometer. The pH is 74 micrometer. That's the target. Now, so that this target will have a reasonable degree of liberation, and also the size is suitable for the next process. Okay. Okay. Now, maybe the technique of a size reduction circuit could be like picture A, maybe B, maybe C. Yeah, maybe 3 stages like this, and the last stage is enclosed circuit, and then the next stages is 2 stages of grinding. Open circuit at the first grinding grinding stage, and a closed circuit at the last stages. So the final product is this is the final product of size reduction circuit. The circuit like this usually is called as conventional size reduction circuit. The other technique may be like this: just primary crusher, and then using autogenous mill, a closed circuit the cyclone may be enough to have only like at this stage, depending once again the size of the original ore and also the mineralogy. Or maybe like this. Yeah. So there are a couple design in terms of a size reduction circuit. Usually the grinding, usually the grinding based on tumbling mill, which basically a cylinder which is a rotated a cylinder. That's the basic principle of the grinding method. So that's why it is in general called as tumbling mill. The other method, okay, so the first conventional method, which is usually used widely in industry, is by tumbling, which basically rotated a cylinder. It could be, for some cases, by stirring, or even by vibration. That's the development of a grinding method. But steering, it is for some cases, especially if we need to find a finer particle. If, for example, until 74 micron, usually by tumbling is enough. But if we need even a finer particle, for example, 10 micrometer, maybe by tumbling is not enough. So it could be completed by steering, for example. Here is some example of the steering mill. Here, a tower mill. This is the vertimill or tower. Sorry. Sorry. Vertimill, tower mill, agitated mill, isomill. Isomill is basically stirred mill. Once again, this mill, stirred mill, is usually used whenever we need even finer particle. For grinding, here is the grinding mill. Okay. Okay. Now, in terms of concentration, firstly about the gravity separation. In the picture or graph here, you can see the relationship between particle size and the technique of gravity separation. Start from static heavy media, dynamic heavy media, water-only media, jigging, switchbox, Richard cone, etc. And the capability of each equipment regarding with the particle size. So if you look at here, in general, gravity separation is only effective for a particle, for a bit coarse particle. That's the limitation of a gravity separation. If we compare among the concentration technique, the advantage of gravity separation is it is easier to operate it, usually more economics, more economic, but the limitation is the size of particles. If the particle in very fine particle, usually gravity separation is not effective. Okay. Okay. Here is the example of the switch box. One example of gravity concentration. This picture, I taken this picture in Bangka Island. In this case, there are two sluice box. There are two sluice box treated tin ore. In this case, tin ore, alluvial tin ore. Alluvial tin ore. So in terms of alluvial tin ore, this ore, the particle in general is already liberated with the size of a bit coarse size. So it's quite effective, even though we need more stages to increase the grade of the cassiterite as a mineral of tin. Look at here. This is a very simple in principle of the sluice box. This is the slurry. We transported the slurry to the sluice box, and then the slurry will flow on the table, like a table here, and then the heavy particle will stay in the deck, but the non-heavy particle will flow through the table, the deck, the sluice box, so that we can separate heavy particle, big specific gravity, high specific gravity of particle separated from the light particle. Okay, so then we can have concentrate. Look at here, that's the principle. So the basic principle of the sluice box is a sluicing effect, which basically thin flow film of the slurry. Look at the white in color of the particle. Here is the light particle, and the black one is a heavy particle. So then we can separate the heavy and light particle. Here is the jig. Okay, the basic construction of jig. The basic construction of jig, and this example is a Denver mineral jig. Okay, so sorry. So basically, if you look at here, the basic principle of a jig is based on different of gravity, a specific gravity of the particle. Okay. Here is the shaking table. Look at here, the shaking table, which basically table, and this table will shake the particle flowing on the top of the deck, on the top of the table. So then the feed in the form of slurry will flow on the top, and then because the mechanism of the gravity and also the shaking by a drive head here, and then a particle will separate based on the specific gravity. So then we can have concentrate, middling, tiling. Concentrates usually is a heavy particle. The tiling is light particle. And in between is called the middling. Usually the middling need other stage of concentration process. Here is a spiral concentrator. You can see the photograph of the spiral concentration like that. You can see how each particle separate and the flow. Yeah. You can see the color here. Heaviest, middling, and lights. Yeah. You can see the flow. Yeah. Okay. So that at the bottom, we can separate three types of the slurry. So we can have the heaviest slurry, which basically concentrate, the middling in between of concentrate and the tiling. Okay. The other technique is centrifugal concentrator. Okay. A centrifugal concentrator, as an example, is a Nelson concentrator here. So you can have a look here, the picture. It's basically a bowl with a rifle here, so that whenever the slurry is fed from the top and then go down, and then because the rotation of the bowl, and then the slurry will go up during the go up, because the centrifugal force, the heavy particle will attach to the wall, whilst the light particle will go with the slurry, and then it is it will be tiling. After that, stop for a while the slurry, and then we can flush the concentrate. So we can separate the concentrate from the tiling. The other example of centrifugal concentrator is here. Falcon concentrator. This one is a Falcon concentrator. Similar mechanism with Nelson concentrator, yeah? But different design, especially regarding with the bubble here. But in general, the principle is similar. The other example is here, multi-gravity separator. I've taken this picture was taken a couple years ago at PG Timah, yeah, which basically treat alluvial tin ore using a multi-gravity separator. So in the principle here, you look at here, so this is basically a cylindrical shaking table. So a cylindrical drum, cylindrical drum, and then also there is a shaking. So that's why it is called cylindrical shaking table, a shaking of the drum while it is in rotation. So that whenever slurry is fed from here and then go to the inside of the drum, and then there will be a separation between the tiling here and the heavy particle, which is a concentrate. Okay. Because the time limitation, I cannot explain a bit more detail of each technique of the concentration. The other technique, rather than gravity separation or gravity concentration, is magnetic separation. It could be in wet or dry, for example, here. So basically, in this technique, we can separate magnetic material, magnetic mineral from non-magnetic material. For example, here, look at here the slurry, go to the equipment, to the magnetic separation, and then after a while, a particle having a magnetic characteristic will attach to the rotor here, and then go with the rotation. After that, it could be separated, become magnetite material, while non-magnetic material, because it is not attached to the rotor, to the drum, and then we can collect here as a tiling. So that's the basic principle. Separate between magnetic material and non-magnetic material. Usually it is performed or done with multi-stages, because usually if only one stage, the product, is especially the grade of the product, usually is still not achieve the target. So we need some stages. For example, here 3 stage. Okay. The other technique is electrostatic separation. Okay, it is on the example with electrodynamic separator or high tension separator or electrostatic separator. If you look at here, this is the drum, earthed drum, and there are 2 electrodes, ionizing electrode and static electrode. So this electrode will bombard, will spray the ions to the particle, so that the particle having electrical conductivity will respond differently with non-conductivity particle, so that we can separate among the conductor, non-conductor, and a middling. In terms of electrostatic separator, in this separator there is only 1 electrode, and then separate the non-conductor and conductor. Okay, this is the picture, the example of the picture of electrostatic separator I took a couple months or a couple years ago at PT Timah, Bangka Island. Look at, there is 2 drum here. Each drum has electrodes. The limitation of this technique is the capacity usually is quite low because we need the layer here. The layer is a thin layer, should be a thin layer. It is not allowed to put a very thick layer because the process will be is not efficient. So that's why you look at here, a thin layer on the top of the drum. Yeah, you can't put too thick layer. If a too thick layer, maybe a lot of particle is not good in response to the ion supplied by the electrode here. Now the flotation. Okay. Look at the picture here. The picture here will show you the principle of flotation, a kind of flotation. This is a tank, flotation tank. And this is the impeller, so that whenever the feed is fed to the tank, we need the slurry mixed well, okay, in the form of we need to disperse the particle to the whole slurry inside the tank. Okay, and then so that we need the impeller. We need to operate this impeller with a right impeller speed, because if the impeller speed is too low, then maybe the level of turbulence is not enough to disperse the particle quite well. If the impeller speed is too high, maybe the level of turbulence is too excessive, and then it will give a bad impact to the flotation process. Okay, so that's in general. So, and also we need to flow the air, and then the air will go through the pipe of the impeller, and then because the action of the impeller, this air will become a bubble, so that the bubble will be produced inside the tank, so that because the level of turbulence inside the tank, the particle and the bubble will meet together, so that for a particle, if you look at here, for some particle, the particle will attach to the bubble, some particle will not. A particle that is attached to the bubble is called as hydrophobic minerals, and the particle which is not attached to the bubble is called as hydrophilic minerals. So that the hydrophobic particle will attach to the bubble, go up to the top of the slurry, and then become froth. This froth and then is flow to the launder, become concentrate. So that's the basic principle of the flotation. Yeah. The key of this process is the surface characteristics of the particle, whether it is a hydrophobic particle or hydrophilic particle. Usually, naturally, most of the mineral basically is hydrophobic minerals. Yeah, only few minerals is hydrophobic minerals. Yeah. This is the function of the reagents, flotation reagent. So that's why we need the chemical reagent. to modify some particle which basically hydrophilic mineral become hydrophobic. So this is the key. Whenever the reagent is not effective in modifying the surface of the mineral, so then the flotation will be not effective. So that's so one of the variable that determine the performance of flotation is the function of a chemical reagent. Okay, this is the example. A laboratory then for flotation cell. Look at the plot here. Okay? And some example of the kind of a flotation cell. The picture show the Outokumpu flotation cells. So the design in the mechanical flotation basically is the design of the impeller or the rotor, and the modification the environment in terms of, for example, here the stator. This is the WEMCO flotation cell. Yeah? Outokumpu, the WEMCO flotation cell, and the other example. Okay. Usually, in industrial plant, it is not enough if only one stage of a flotation process. We need a couple stages of flotation process. For example, here, this is the example, typical flotation flow sheet used for complex copper, lead, zinc, sulfide processing. In this case, we have ore having valuable minerals, a copper, a lead, and zinc. So this is why it is called as a complex sulfate minerals. Look at here, the stages. And this stage become a circuit, quite complex circuit in having to produce, for example, here at the end from the feed, copper concentrate, zinc concentrate, lead concentrate, and even blood concentrate of zinc and lead. Just for example. So usually, once again, in a flotation, that is not enough. There must be a couple of stages. In design, in designing the flotation process, usually we need to excessive experiment for a typical, for a specific feed in the lab to come up with the design of the flow sheet to run the plant effectively and produce the concentrate with the target grade of each element, for example, target of copper, target of lead, target of zinc, according to the requirement. Okay, this is an example of mineral processing at PT Freeport, Indonesia, yeah, which is a very large plant. In there are basically 4 plants: concentrator 1, 2, 3, 4, and the concentration process basically is a flotation. PT Freeport, Indonesia, the location is in the Papua Island. Look at here. If you look at the Indonesian map, so in the eastern part of Indonesia, there is an island, and this island separated between the western part is belong to Indonesia, and the eastern part is belong to PNG, Papua New Guinea. And around here is the location of the mine and the plant. This is an example, one of the mine site at the PT Freeport Indonesia, Grasberg open pit mine of large mine area here. Okay. And this is the illustration of the ore body of PT Freeport Indonesia. If this is the open pit mine, look at here, open pit mine, underneath there are still a couple of ore body. For example, a Big Gosan, Kucing Liar, Grasberg underground, yeah, and this is Grasberg open pit, and also Dom. This is the name of some ore body. Now, from this ore body, with the certain technique of mining, then the ore is sent to the plant. Firstly, still in the mining area, the primary crushing is performed in this mining area. Because the size of the particle is quite big, around 80 centimeter, and then reduced by using gyratory crusher, the product of gyratory crusher, and then send via belt conveyor to the plant. This is the general flow sheet of PT Freeport Indonesia mill plant, just for two plant, north concentrator and south concentrator. How the run of mine resulted from the mining activity go to primary crusher. Primary crusher is still in the mining area, and then after that sent to the stockpile area in the plant area, and then go to primary screen, secondary crusher, secondary screen, and so on. So basically, there are three stages of crushing, and then grinding. After that, flotation. First is of flotation, which is aerobic flotation, and then grinding again, or it is called a regrinding. After that, go to cleaner stages. Cleaner scavenger column, raise scavenger, and so on. So then at the end, the concentrate will be produced. If the grade in the ore, the copper grade usually less than 1% copper, usually around 0.8, 0.9, even 0.7% of copper, and then concentrate will be produced in the grade of around 20, more than 20% of copper, which is this grade is the limit of fit for a smelting process. Okay. Just for example, this is the main equipment of PT Freeport Indonesia mill plant, the grinding and the flotation cell. This is the table of a plant performance data, the capacity from, just for example, from the year of 2005 until 2009. This is the capacity of the mill, the recovery of the copper, the recovery of the gold, and also the amount of the concentrate, a million metric ton per year. And then the grade of the copper. Look at here, good grade of the copper start from less than 1% in the ore, become concentrate with the grade of 30, 27, 28, 29, even though at the moment currently around 25, even lower than 25, because more complex ore treated in the plant. Okay, that's all in general of the part 2, which is physical separation of primary resources. Okay. Now the part 2, physical separation of secondary resources. Okay. About the secondary resources, this is the table, the classification and structure of used PCBs. Look at here, the source of PCBs from laptop computer, mix, mobile phone, PC, printer, and the weight of each element: copper, iron, aluminum, lead, nickel, tin, the weight and percentage, weight and milligram per kilogram, and this is the total. Okay. And look at our laptop, PCBs of our laptop. With the content, metal content, you can have a look at the tables. Yeah. This one from mobile phone. Yeah. This one from PC, PCBs of the PC, and this is from a printer. So this is the visual look like of the secondary resources. And this case is used PCBs. So if in the primary resources, the basic principle is how to separate valuable minerals from the gangue minerals in the ore. For secondary resources, how to separate the metal element. Now, because the source is secondary resources, and not if the secondary resources is mineral, so the element, the component is minerals, how to separate mineral from the other mineral. Here is how to separate especially metal from non-metal. And then among the metal to separate the other metals. Look at here. Maybe this is the metal, and the green in color is not non-metals. You can have a look here. Mostly, if you look at here, mostly the content of the secondary sources, in this case the PCBs, mostly is copper. Look at here, copper, and then also iron, and the other. Then mostly the highest content is copper. Okay. Okay, this is the the figure of PCB's particle. One is free metals, 2 free plastic, 3 local plastic, free board pieces, locked board pieces, 6 free ceramics, and number 7 locked ceramic. So if we can compare with the primary resources, how the mineral in association with the other minerals naturally. Here you can have a look some example of the PCBs, how they associate among the other metal or non-metals. Yeah. Based on layer number and shape, the classification of PCB can be divided into based on the layer number, single-sided, double-sided, and could be multi-layer, where the shape could be rigid, flexible, or the mix between flexible and rigid. That's the physical characteristic of a is based on layer number and the shape of the layer. In terms of properties and characteristic of metal and non-metal, here the comparison. So properties and characteristic of mineral based on specific gravity, electrical conductivity, hydrophobicity, and amount and fit. A metal content in the secondary resources usually has a specific, high specific gravity. Non-metal is low specific gravity. In terms of electrical conductivity, metal content is very high. and non-metal is very low. In terms of hydrophobicity, naturally the metal is very low, but non-metal high. Hydrophobicity is the tendency of a particle to attach to the bubble. So the high hydrophobicity means easy to attach to the bubble. And the other characteristic is the hydrophilic, which is difficult to attach to the bubble. If difficult to attach to the bubble, mean easy to be wetted. Sorry. And the term of mount in the feed, the composition. Usually the metal height at coarse a fraction, yeah. But in fine fraction, but usually in a fine a fraction. So if you look at here, because the basic principle and the mineral processing is based on the different characteristic of the mineral, weight, the specific gravity, electrical conductivity, the magnetic characteristic, hydrophobicity, it is also happen in the secondary resources, so that in the principle we can apply the principle used in the primary resources to the secondary resources based on the different characteristic of the metal and non-metal. Okay. It is an example, the X-ray diffractogram of waste motherboard PCB. Look at here. The element could be copper, silicon, nickel, iron, aluminum, tin, lead, bromine. Okay. If this picture shows the same image of waste motherboard PCB, this is the source of the reference. Okay? And look at here. If we analyze this same image, and then we can have a look some area 1, 2, 3, 4, 5, 6, and some spots 1, 2, 3, 4, 5, and then for specific area and specific spot, the composition, the element, you can have a look here. So, for example, the copper and area 1, mostly copper and aluminum and oxygen as oxide. Yeah? And the other area could be a bit different. So this a typical same image of the waste motherboard. If we compare to mineral, usually we also analyze the mineral, the concentrate, the ore, the tiling using same technique. Same technique to have a look the minerals, typically minerals, because in primary resources, the element, the smallest element is mineral, whilst in the secondary resources, because it is comprises of metal and non-metal. So no more a mineral here, but metal. You know? So that how to separate this metal from non-metal. Okay. This picture showing the small-scale PCB recycling plant layout. Yeah. Look at, firstly, we need to dismantling a machine. After that, we need the crusher, grinding machine, or milling machine. And also we need to separate the dust, because usually it is operated in dry grinding, dry process. So we need to separate the dust using dust collector. So basically, crushing, grinding. as also apply in the primary resources with different ways, but basically the state is the same, crushing and then grinding, whether only one stage or maybe need 2 stages, etc., depending on the source. After that, I will look at here. There is also cyclone here to separate the size of particle, coarse and fine particle. After that, the technique and concentration, in this case, using electrostatic separator. So the separation among the particle based on the electrical conductivity. After that, the other stage based on magnetic separation using magnetic separator. So that also with the cyclone here to separate the fine particle and a coarse particle. So pretty much at any stage of this recycling plant is in terms of the technique, crushing, grinding, separation, electrostatic separation, magnetic separation, etc. It is quite similar with the technique and for primary resources. But once again, the mechanism a bit different. The kind of crusher could be different. Yeah. Even though the basic principle, which is how to reduce the size, that's the basic principle, but in a mechanism a bit different. And also to the grinding of a machine or grinding equipment. Okay, look at here, it is example, crushing and beneficiation system. Yeah? The source is from this paper. Yeah. From a raw material, and then firstly using a shredder, and then using a hammer grinder. A shredder basically like crushing, grinder, one stage, second stage, and then using also cyclone, other cyclone, because that could be produce some dust. We need dust collector. And then also using cyclone, vibrating screen. So everything here, until here, everything is about the size of particle. Crushing, grinding, sizing, which could be cyclone, and a screen. It is all about a size of particle. And then after that, the separation among the particle based on the characteristic of particle by using the electrostatic separator. So that we can produce non-metal and metal recovery. In this report, it is reported that non-metal recovery, usually we can recover 100% of non-metal. But usually for metal recovery rate is about more than 95%. In this case, I think it is quite good in terms of recovery. Okay. You can have a look here, a crusher. If in the primary resources, the most common crusher is choke crusher and giratory crusher. And the secondary resources, if we look at here, the kind of crusher is a bit different. Yeah. Look at here, for example, a shearing machine, and here hammer grinder. The reference from Huang et al. 2009. Yeah. Here is the other example for the other crusher. Look at here, a PCBs, use a PCBs, and then using a kind of crusher here, so we can produce a mixed particle with a reduced size. The mechanism like this, it could be the principle how to reduce the size of the particle. Okay? For example, impact force, grind force, using hammer crushing. So the material put in to the equipment, and then there is a hammer here, hammer in rotation with usually high speed of hammer, so that the particle will will meet with the, not only meet with the hammer, but there will be impact to the particle. So that's why the particle will break into smaller particle. So that are the basic principles. The other example of a crusher, look at here. In this case, there is a rotary blade. In primary resources, it is not common to use rotary blade, but for the secondary resources, may be quite common to use rotary blade in the crushing stage. Okay? Crushing, grinding, or flotation. Look at here, the feed, and this is for flotation. But look at first for the hammer mill, a crushing chamber, and screen use in the experiment, comminution experiment. Look at here, the hammer mill. It is the screen, yeah, and also the circuit here, so that we can produce the feed like this. After crushing and grinding, the feed is treated by a flotation technique. So we can have the froth product and a non-froth product. Froth product is comprise the particle, hydrophobic particle, which is basically non-metals material, non-metal material, and non-froth product is basically metal materials. Okay. So we can separate by physical separation of the secondary resources with the product of non-metals and metals. Okay. Here is the basic principle of the flotation, and the feed is from secondary resources. So this is the particle, and the color of particle show the element, the metal and non-metal. So copper is brown in color, aluminum, zinc, atometal and yellow, non-metal black. Look at here, the picture like this, how the particle attached to the bubble, and the white in color is air, a bubble. During the flotation, the particle which is easy to attach to the bubble will attach to the bubble and then move upwards, become the froth. And in this case, the froth is tilings because it is non-metals. The tiling is the froth, and a non-froth product is a concentrate because it is comprised of metals. Okay. In flotation, the basic principle of the flotation, if we produce the froth, which are basically comprised of valuable mineral, then the flotation is called as a normal flotation. if we do the flotation and produce the froth, which basically the tiling, so then the process is called as a reverse flotation. So for this example, for secondary resources, the basis of flotation is basically is a reverse flotation, because we float, produce the froth, we float the gangue particle or non-metal particle. Sorry, I need to plug it in the power source for a while. Just wait for a while. I need to connect my laptop to power source because the power nearly finished. Okay. So it is an example how reverse flotation is applied for flotation of secondary resources to separate the metals and non-metals. The non-metal is floated. The metal is still stay in the flotation cell. And then we can separate between the non-metals and metals. And primary resources, depending on the characteristic, the grade of the ore, we can apply the normal flotation, which is floating the valuable mineral, for example, like at a PT Freeport, Indonesia, or we can also apply the reverse of flotation. And look like in the flotation for secondary resources, look like mostly in terms of separating the non-metal from the metal, look like the flotation is much suitable for reverse flotation, which float the non-metal or a gangue material of the feed. This is the example, just an example of the balance of load sheet of a physical separation of PCBs. The data is processed from the reference of Sarfar et al. And Das et al. And the data then collected and then processed to this flow sheet. So, for example, waste as the feed, and then with this flow sheet, start from a combination, especially because waste is here already performed by a crushing, and then the grinding, screening one here, and other screening maybe screening, and then a jig, using jig, pulverizer, screening, flotation, multi-gravity aspiration, as flotation, MGS, high tension, electrostatic aspiration, and so on. So this is just a combination. So in total, if you look at fit from 100, say 100 ton, 100 kilogram stream. The recovery. Look at here the stream, and then the yield, the grade, and the recovery. Then we can have a look here from this circuit. We can have concentrate 1, concentrate 2, concentrate 3, concentrate 4, and the concentrator with the recovery around 7.70 with yields yield is weight of the concentrate, the ratio of the concentrate weight to feed weight. 40.38 when the grade of the metal is around 80.71. Just example, the flow sheet. So if you look at it's a process here, grinding, screening, flotation, concentrating using a multi-gravity separator, and at the process, it is the basic. Basically, it is also the process for primary resources. That's the similarity between processing for physical separation for primary resources and physical separation for secondary resources. But once again, even though in principle using same technique, but the detailed process is a bit different. I think that's all what I can present in this time. Thank you. Terima kasih. So then back to Pak Imam. Pak Imam.
Yes. Thank you, Pak Edi. Is my voice clearly, guys? So right now we will have question and answer. So you can type your question in the chat, or you can raise your hand and then I will select the participant to ask to Pak Edi. So don't be shy. Usually Pak Edi student is shy to ask, so please ask everyone. If you have any questions, please ask to Pak Edi directly and show your camera, or you can type in the chat.
Let's see the other participant, Pak Imam.
Yes.
Okay. So if there is a question, just
yes,
just mention your question. But firstly, please mention your name and your institution or maybe your company before asking the question. No question?
Usually there is Pak in the chat. I will. It is
cannot see
Adelia Ardiana, Pak Edi.
How to see the chat?
I will read for you, Pak Edi. Good afternoon, sir. I want to ask about the development secondary metal production. More generally, the competitiveness of secondary metal production is hindered by a number of factors. But on the other hand, primary metal production is relatively electricity intensive, and this electricity is often generated using higher proportion of fossil fuels than that used by secondary sector. The question is, can secondary metal production dominate over primary metal production in the future? And what effort can be made to increase secondary metal production? It is from Adelia Ardiana, Pak Edi. Yes.
Okay. If I'm not wrong, what Adelia mentioned about secondary metal production. In my term, the term is firstly is primary resources, because in primary resources we do not produce metal. All right. We do not produce the metal. We still produce in the form of mineral because the source is a mineral. This firstly. Okay. For the secondary resources, maybe it is also, I think we can also say the metal production, because the product is metal, even though the metal is produced because the feed is in the form of metal, right? So metal to the metal. Remember, in this case, the process is a physical separation. So physical separation mean the separation of the separation of if the source is metal, so and the source is metal, non-metal, so then in this case, and the physical separation is how to produce or to separate the metal and non-metal. So it is, yes, so we can say the metal production because usually the just to make not confusing with the metal production in terms of extraction. Yeah. Yeah. Okay. I think if we compare the process from secondary, so I think if I'm not wrong, the comparison of primary resources and the secondary resources based on advantage and disadvantage of each process, and then the question is whether in the future the process of secondary resources will dominate the overall process. I cannot answer clearly about this, but I think we still need the primary resources. Yeah, I still think we still think we need the primary resources. Maybe because for other case we still need metal, for example, rare earth metals, or something like that, which basically from the primary resources. Okay. Secondly, whether the secondary will dominate, I can't answer that. I don't have any data showing the increase of application of the process for secondary resources. To be honest, maybe other participant can show the statistic, and then we can compare the production, and then comparing this to resources. Yeah, sorry, Adelia. In terms of energy, I think we cannot compare directly because, for example, the equipment, the stage of equipment quite similar. There is crushing, there is grinding, there is concentration. In terms of energy usage, yes, we mostly still use fuel, fossil fuel. Okay. Remember, the problem with the fossil fuel is the emission, and because remember that Indonesia still has quite big number, the amount of the fuel sources still significant. Maybe the question is how we can use this fuel with cleaner energy. That's the effort we need to think. Yeah? How we still can use for example, in my opinion, a fuel source, but with cleaner, with the emission, a lower and lower and lower emission. That's the other thing. Okay. Whilst in parallel, we also try to use renewable energy with the cleaner Right. So I think at that stage we cannot leave our primary resources in terms of energy, fuel energy, because we still need that, yeah, for the sake of our country, I think, to be honest. But we try to eliminate the emission. How do we can eliminate the emission? Yeah, not just transform to renewable energy for the whole, because remember, to use renewable energy still need high capital expenditure, yeah, which very costly at the beginning. Yeah, remember also about that. The other hand, our resources still produce benefit for our country. So we need to think also about that, how to eliminate the emission, but still use our resources wisely, yeah, according to, yeah, wisely, environmentally. That's, I think, our effort to do that. Yeah. So to be honest, I cannot predict or estimate whether processing for secondary resources will dominate the process for secondary resources, because I don't have any data about that. Sorry for that. But I think in terms of recycling, it is an opportunity to use physical separation technique in order to recover the metal in the waste or use material such as PCBs. I think that, and how to always also increase the recovery, the grade, and so on, or to have more efficient the process. That's, I think, my answer, Pak Imam.
Okay, thank you, Pak Edi Sarwani. Is there any more question, guys? We still have 3 minutes.
Maybe
You
in the
can
chat,
raise your hand.
Pak
Oh yeah,
Imam?
in the chat. Yes. Oh, Adilat say thank you very much. Thank you
Okay.
very much.
Ada question in the chat? Maybe?
No, Pak Edi.
Oh, okay.
Okay, guys, you can raise your hand directly. Don't be shy. 2 minutes, but anyway,
Okay.
I count until 5.
I think that's all, Pak Imam. If there is no more question,
Yes.
I think.
Okay. Okay, Pak Edi, thank you very much. It is perfectly, the time is now is 2 minutes to 12 here in Helsinki. And again, thank you very much for the lecture today. And okay, everyone, see you again tomorrow. See you soon again. Bye-bye.
Okay. Thank you.
Thank you, Pak
Bye-bye.
Edi.
Now, how to
Stop scare, Pak. You can leave. There is like in the